Okay, welcome to video tuition lesson number 2. This time we're going to be looking at numbers written in power or index form. This very often crops up in GCSE questions, especially in the non-calculator papers. Okay, let's kick off by looking at an example, some simple examples. 2 to the power of 2, as I'm sure many of you will now know, means 2 times 2. And 6 to the power 3, or 6 cubed, means 6 times 6 times 6. I'm sure most of you will have seen things like this by now. But what about things like this? What about 8 to the power of a third, or 5 to the power of minus 2, or 27 to the power of minus 2 thirds? Here we have a negative fraction as the power. Here we have a negative integer as the power. Here we have a positive fraction as the power. What do they mean? How do we make sense of these, and how do we actually manipulate them or use them in calculations? Well, before we can go into that, we need some rules about working with numbers raised to certain powers. And the first rule we need to look at is what happens when we multiply numbers raised to powers. Let's look at the first example. Here we have 4 to the power of 2 multiplied by 4 to the power of 3. Well, 4 to the power of 2 really means 4 times 4 multiplied by 4 times 4 times 4. This 4 times 4 times 4 is the same as 4 cubed. There we have it, sorry. 4 times 4 is this 4 squared, and it's multiplied there, and it's 4 times 4 times 4. This 4 times 4 times 4 is that 4 cubed. Now, how many 4s are being multiplied together? 5 of them are. So you can see that all of this can be written in a short form as 4 to the power of 5. Well, could we have got there in one short step? And the answer is yes, if we had simply added the powers. 2 add 3 is 5. We didn't have to write out all of that. We could have just added those 2 powers and written 4 to the power of 5. Okay, so that leads us to the following rule, okay, that when you are multiplying the same base number, which in this case was 4, you just add the powers. Okay? What about a thing like this then? 3 to the power of 2 times 7 to the power of 3. Isn't that just 3 to the power of 2 add 3, where we add the powers? Certainly not. The reason you can't do this is that this 7 and this 3, the base numbers, they're not the same. So this makes absolute nonsense. This cannot be done. What you would have to do to work out that is work out this separately, work out that separately, and then multiply your answers. But just adding the powers makes no sense whatsoever, because these base numbers 7 and 3 are different. So never do a thing like that. Okay, let's do one more example, and here we've got starting to use the ideas of the fractions, fractional powers. Simplify 3 to the power of a fifth times 3 to the power of 4/5. Well, the rule said if the base numbers are the same, 3 and 3, then we can just simply add the fractions. Well, we do that. Here I've written 3 to the power of that adding of the fractions. Well, 1/5 add 4/5 is 5/5, and 5/5 is another way of saying 1. So that's 3 to the power 1, which is the same as 3. So all of this simplifies to just 3. Let's do another example. Let's supposing it says now simplify this, 5 to the power of a half times 5 to the power of minus 3/4. Now this minus sign is very, very important to watch out for. The rule is, if the base numbers are the same, and they are, they're both 5, we can just add the powers. So we do. But we add the powers, taking great care about this negative sign, this minus 3/4. So this becomes 5 to the power of a half plus minus. Now that plus minus will change to a minus. So it's really a half minus 3/4. Now a half minus 3/4 is minus a quarter. So this simplified is 5 to the power of minus a quarter. We have still added the powers when we are multiplying numbers, same base numbers, to the various different powers. Okay? Now, let's move on and see what the rule is for when we divide numbers that are raised to different powers. Here we have, for example, or we're going to do this the long-winded way and then see how it is shortened. 5 to the power 6 divided by 5 to the power 4. Well, 5 to the power 6 is all of that. 1, 2, 3, 4, 5, 6. So 6 5s being multiplied together. All divided by, so it's all over, 5 to the power 4, which is written out in the long way as this. There are 4 5s all together being multiplied together. And if we look at that, we can actually cancel off all these 5s. 1 5 off the top there with 1 on the bottom there, another one there, another one there, 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom. That leaves us, as you can see quite nicely, with just these 2 5s left. 5 times 5, and there it is, 5 times 5, which is another way of saying 5 to the power of 2. Well, the question is, can we get to this answer of 5 to the power of 2 in a quick way without having to go through all of this writing out and cancelling? Well, looking at the original powers, 6 and 4, you can see immediately that yes, we can get to this answer very quickly. We can take away the powers. So when we're dividing, we can subtract the powers. So 5 to the power of 6 divided by 5 to the power of 4 is 5 to the power of 6 take away 4, or 5 to the power of 2. Notice the base numbers 5 are the same. So this only makes sense, this method, if the base numbers are the same. So the rule is, if I can just get it up there nicely on the screen, is when dividing the same base number, you just subtract the powers. Okay? Now let's do this with some fractional powers this time and see what happens. Okay, here we are. It says simplify 4 to the power of a half divided by 4 to the power of 1/3. Well, the base numbers are the same, 4 and 4, so we can use the rule. And the rule is that when you're dividing, you can subtract the powers. Now, you are being asked to subtract the powers here, and a half minus a third, you should know by now how to do that. That is 1/6. So this thing here, 4 to the power of half divided by 4 to the power of a third, will simplify to 4 to the power of 1/6. Finish. End of story. Okay, let's move on to another example, and let's supposing this time you're being asked to simplify 6 to the power of 9 divided by 6 to the power of minus 3. This minus sign is going to affect the result very radically, so keep an eye out. Here we are. We still obey the rule. We are dividing, so we subtract the powers. There it is, 9 subtracting the power of minus 3. This minus and that minus, as you probably all know by now, change to a positive, a plus. So you end up with 6 to the power of 9, add 3, and that gives you 6 to the power of 12. The power of 12. Okay, now this idea of dividing numbers raised to certain powers brings up the question, what is any number raised to the power of 0? Okay, for example, what is 2 to the power of 0, or 5 to the power of 0, or even a decimal, 1.5 to the power of 0? What do they mean? Well, let's see if we can do it the long way, and it should make some sense. Let's supposing you had to work out this number. 3 to the power of 4 divided by 3 to the power of 4. Well, the rule says you subtract the powers, and we do exactly that. 3 to the power of 4 take away 4, and those two 4s taken away give 0. Well, what on earth does that mean? Well, let's look at what this also means. Well, 3 to the power of 4 divided by 3 to the power of 4 also means this. It's 3 to the power of 4 divided by 3 to the power of 4. And this means 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. And that is the same there. You have on the denominator 81, you have on the numerator 81. Well, when the numerator and the denominator are equal, then the whole fraction must be 1. Now that must mean that 3 to the power of 0 is 1. Okay? And this is true for any number raised to the power of 0. The answer is always 1. If you don't believe me, put in any number in your calculator and raise it to the power of 0, press equals, and you'll find that it equals 1. You must, by the way, also know how to use the power button on your calculator. It's a very, very useful button. It'll be written down as y to the power of x. Sometimes on some calculators it's x to the power of y. But it's a very, very important button to get to know how to use. Okay, let's see now, let's move on now to looking at negative powers. Okay, now let's go straight into an example. Supposing you had to simplify this. The two base numbers are the same, 3 and 3, so we must subtract the powers. So we do it like this. 3 to the power of 2 minus 7, it's minus 5. Okay? And if we did this the long way, okay, we would write 3 to the power of 2 on the numerator, so it's 3 times 3, and on the denominator we'd put this thing here written out fully. 1, 2, 3, 4, 5, 6, 7. There are 7 3's being multiplied together, but of course we can cancel 1 3 on the top with 1 3 on the bottom, another 3 on the top with another 3 on the bottom, and this would leave us with 1 times 3 times 3 times 3 times 3 times 3 along the bottom. How many 3's are being multiplied together by themselves along the bottom? 5 of them are. So this is the same as 1 over 3 to the power of 5. Now, this must mean that 3 to the power of minus 5, which is the negative power we got applying the rule, and 1 over 3 to the power of plus 5 are the same thing. Okay? We don't bother to write the plus there, it's just self-understood that it is plus. But the important thing to realize is that this 1 over 3 to the power of 5 and this 3 to the power of minus 5 are just two different ways of writing exactly the same thing. Okay? Very important idea. Let's move on to the next idea. And it may say, in this example, that you've got to show that 5 to the power of 3 divided by 5 to the power of 6 is the same thing or equals 1 over 125 or a 125th. Well, all we have to do is to apply the rules in this way. 5 to the power of 3 divided by 5 to the power of 6, the base numbers are the same, so we can just subtract the powers. So we get 3 take away 6, which is 5 to the power of minus 3. Well, we've just shown that a negative power, 5 raised to a negative power, is exactly the same as 1 over 5 raised to the positive power, 1 over 5 to the plus 3. Well, 1 over 5 to the plus 3 is the same as 1 over 5 times 5 times 5. Well, 5 times 5 times 5 is exactly 125, and you have shown that 5 to the power 3 divided by 5 to the power 6 is that fraction, 1/125th. There it is. Also, don't forget, let me get this in the right position, there we are. Also, don't forget that if you can say that 6 to the power of minus 2 is another way of writing 1 over 6 to the power of 2, then it's also true that 1 over 6 to the power of minus 2 is the same thing as 6 to the power of plus 2. That these are also the same thing, just written differently. Okay? This looks much more complicated than that, but they are exactly the same things. This looks much more complicated than this, but they are in fact two ways of writing the same thing. Okay? Now, let's move on to looking at what we mean by powers of powers. Let's suppose you had to simplify a thing like that. Now, a power of a power means exactly what's here. We've now introduced the brackets. This is 3 squared, or 3 to the power of 2, inside the brackets, and now all of the brackets is raised to the power of 4. Let's see what this means. Well, 3 to the power of 2 is 3 times 3. We can put a bracket in because we want to show that 3 to the power of 2 all to the power of 4 means this. It means you've got 3 to the times 3 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 4 times. Okay? You've got 1, 2, 3, 4 of these things inside the brackets, and they're all being multiplied together. Alright? Now, you don't need the brackets, and because everything is just multiplied. So if you remove the brackets, you get 1, 2, 3, 4, 5, 6, 7, 8 3's are being multiplied together. So, it's 3 to the power of 8. Now, of course, the question is, do I have to go through all this rigmarole of writing all this out to get to the correct power? Well, if you look at the original, the answer is clearly no. If you've got a power of a power, 2 times 4 is 8. So you don't have to go through all this rigmarole. You can just multiply the powers, which I've got here. So this means 3 to the power of 2 times 4, which is 3 to the power of 8. So this leads you to another very useful rule. Let's get it up on the screen. There we are. When you have the power of a power, you just multiply the powers. Okay? Now, let's see what all this means when it comes to doing things with fractional powers. But first we've got to understand what fractional powers actually mean. And we have to first of all look at how we can rewrite fractions slightly. Okay? This little trick will help you understand powers of fractional powers in a second. Okay, remember you can rewrite fractions like this. Now 3/4 is the same as 1/4 times 3. It's almost as though as if I've moved that numerator to the side a bit and replaced it with a 1. 1 times 3 is 3, 3/4. Another example here, 5/6 could be rewritten as 1/6 times 5. If you multiply those two numerators together there, you get the 5 there, leaving you with 5/6. We have rewritten 5/6 as 1/6 times 5. Okay? That's a little trick which is going to come in handy. Now, unfortunately, this next bit does not come out very clearly with the camera, so I'm going to have to enlarge it in a second. But I want to show you something which is very, very important. If you take the square root of a number, here I've taken the square root of 7, this means exactly the same as 7 raised to the power of a half. Now I've got that little 2 in red, which is the denominator of that fractional power in red. I should be writing a red 2 in front of that root sign, meaning the square root. But traditionally, when you write the root like that, it's traditionally taken to mean the square root, and the little 2 is no longer written there. If you look at very old mathematical textbooks, they still used to write the little 2 there, meaning you are taking the square root of 7. But what I want you to remember here is that the square root of any number is the same as that number excuse me, raised to the power of a half. So for example, the square root of 9 means exactly the same as 9 to the power of 1/2. Square root of 9 is 3, so 9 to the power of a half is also 3. If you don't believe me, use your calculator, raise 9 to the power of a half, press equals, and you'll see it gets to 3. Now here's where I have to use my enlarged handwriting, because these didn't come out very well. Here I've written the cube root of 10. Okay, here's where I'll put in my look, it's come out quite well. If I can stop moving around. Yes, there we are. Here I've written the cube root of 10. This is exactly the same as 10 raised to the power of 1/3. See the 3 on the denominator in the fractional power there. Here I've written the 5th root of 32. That's written as 32 to the power of 1/5. Here, just for fun, I've written down the 10th root of 5. Another way of writing that is 5 to the power of 1/10. These fractional powers are another way of writing these roots like that. Okay? It's very, very important, and it's a very simple idea. important one, of course, is the square root. That the square root, where that would be a 2, but we don't bother to write the 2 in anymore, would give a half, okay? Which I've mentioned. Right, let's see how this works doing actual examples. Here, in this example, I'm saying find the value of 32 raised to the power of 2/5. Okay? Now we're going to use the idea of rewriting this 2/5 as 1/5 times 2. Yeah? So I've started by writing 32 to the power of 2/5 is the same as or equals 32 to the power of 1/5 times 2. I've then put brackets around the 32, and that times 2 is like squaring this brackets. Now inside the brackets, because it's 32 to the power of 1/5, it's like saying, what is the 5th root of 32? Well, the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2, in other words, I've multiplied 5 2's together by themselves, they come to 32. So all of that thing inside the brackets is just 2. The 5th root of 32 is 2. Well, the whole thing's being squared, so that's still there. So 2 squared is 4. So in other words, 32 to the power of 2/5 has the power of 4. If you don't believe me, get your calculator, put in 32 and raise 32 to the power of the fraction 2/5. Press equals and the answer will come out as 4. But this is the way you would have to show it, show your working at GCSE. They want to see that you know what 1/5, the 5th root of 32 is, and you're squaring it. Okay? Let's do another example. Here I've asked you to find the value of 27 raised to the power of minus 2/3. Now, this minus sign, watch out. We saw that if you have a number raised to a negative power, that this thing is really the same as 1 over that number raised to the positive power. So here we've got 27 to the power of minus 2/3 is the same as 1 over 27 to the power of plus 2/3. Now I break up this plus 2/3 to rewrite it as 27 to the power of 1/3 times 2. Okay. Now, if 27 is being raised to the power of 1/3, that is the same as the cube root of 27. Okay? So, all of that is 27 to the power of 1/3, but it's being multiplied by 2, so the whole thing in brackets is being squared. So in other words, I've got to find the cube root of 27 and then square my answer. Well, the cube root of 27 is 3. In other words, 3 times 3 times 3 is 27. So the cube root of 27 is 3. But it's all being squared here. So 1 over 3 squared is 9. So we can say that 27 to the power of minus 2/3 has the same value as 1/9. There it is. You don't believe me? Again, put in 27 into your calculator, raise it to the power of 2/3, make sure it's a negative 2/3, and you'll get the same answer as 1/9. It'll give it in decimal form. Okay? Now, it's very important that you get to know, get to recognize some powers. Okay? You must be able to recognize which numbers can be written as numbers raised to powers. And here, oops, get that on the screen a bit better for you. Here I've made a long list. Alright? 2 to the power of 0 is always 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. These, you should get to recognize these. If you see 64, this should automatically pop into your head. It's really the same as 2 to the power of 6. In other words, the 6th root of 64 is 2. The 4th root of 16 is 2, and so on. Here are some more that you should get to recognize. 3 to the power of 0 is always 1. 3 to the power 1, 3. 3 squared, 9. 3 cubed, 27. 3 to the power 4, 81. Very important. They play around with these numbers in questions, in GCSE questions. If you see 81, you should automatically think it's something to do with 3. Yes, it is. It's 3 raised to the power of 4. So in other words, the 4th root of 81 is 3. The 3rd root of 27 is 3, or 27 to the power of 1/3 is 3. Okay? Here are some more that you should be on the lookout for. Here, 4 to the power of 1 is 4. Don't forget 4 to the power of 0 is always 1. 4 squared, 16. 4 cubed, 64. 4 to the power of 4, 256. 256, very, very significant number. So 64, 16. They're all playing around with these 4s. Here's some more. 5 to the power of 0, 1. 5 to the power of 1. 5 squared, 25. 5 cubed, 125. Here's some more to be going on with. 216, often crops up in non-calculator papers, is really 6 to the power of 3. 36, 6 to the power of 2. Here, we'll be doing an example that involves these in a second, a GCSE example. 10 to the power of 4 is really 10,000. 10 to the power of 3, 1,000, and so on. You need to be able to recognize these things if they crop up in a question to do with powers. So in other words, what I'm saying to you is that if you see the number 27 in a power question, then you really ought to be thinking, this is 3 to the power of 3. If you see the number of 64, you should really think, it's 8 squared, or it could be 4 to the power 3. If you see 32, it's really 2 to the power of 5. Okay? You should get yourselves familiar with these sorts of things. Okay, we now have to move on to actually using these things to solve equations where the unknown is a power. Okay? Let's do an example. Supposing you saw a thing like this. Could well be in a GCSE exam. 2 to the power of 5x minus 2 is equal to 1024. Well, here the unknown is x, and that x is actually part of the power here. It's 2 raised to all of that. Right, in questions like this, the only way you can break into them is to realize that this base number 2 is being raised to a power, and you must get over here somehow the same base number. In other words, you must rewrite 1024 as 2 raised to some power. And with a little looking at using your calculator, or even just using a scrap piece of paper, you should get to the answer that really 1024 is 2 raised to the power of 10. If you see this 2 here, you know that you've got to look for 2 raised to some power. So you can keep on trying extra powers until you get to 1024. You'll do 2 to the power of 5, which is 32. Then you multiply that by 2 to the power 6, and keep on going until you get to the correct power. The important thing is that you've made the 2 base numbers the same. Only when these 2 base numbers are the same in this equation can you say, therefore, that the power on this side must be equal to the power on that side. And if you can do that, you can immediately make that equation. 5x minus 2 must equal 10. Simple as that. You've now got a very simple equation that you can now solve. And let's do that. Here we have the equation. To get rid of that minus 2, I add 2 to both sides. This minus 2 and plus 2 becomes 0. I've now got 5x is equal to 12. Well, that means I've got my x being multiplied by 5. To get rid of this multiplication by 5, I've got to divide both sides by 5. And this 5 and that 5 can cancel off, leaving me just with the x, and I have my final answer that x is equal to 12/5, written like that. Don't be surprised if x comes out as a fraction. Here it's a top-heavy fraction, an improper fraction. No one said x would be a nice positive whole number. It can come out as a fraction, could come out as a negative fraction. Don't worry. If all the mathematics here is correct and that's your answer, then stick to it. Okay? Here's another example. It says find Q, let's get it in the right place, find Q if 2 to the minus Q is 128. Well, again, you see this base number 2. That should say to you, how do I rewrite 128 as 2 raised to some power? Well, a little trial and error on your calculator, or even a trial and paper with some paper, should show you that 2 to the power of 7 is really 128. You have now got the base numbers the same. 2 on that side, 2 on that side. Only when these 2 base numbers are the same can you say that this power must equal that power. So therefore, minus Q must equal 7, or Q is the same thing as minus 7. I've just multiplied both sides by minus 1 to give me plus Q there. And so Q is minus 7. Very simple idea. Now let's look at something that gets a little bit, looks a bit more complicated, but in fact it isn't. What is the value in this example of 8 to the power of minus a third, brackets, all to the power of minus 2? How do we work this out? Well, I'll move that up slightly. Well, first thing, remember, it's the powers of the powers. So we multiply the powers. Okay? So we're going to be multiplying minus 2 and minus a third. And a minus times a minus gives a plus, and a third times 2 is 2/3. So that's very easy. So 8 to the power of minus a third times minus 2, this thing here, is 8 to the power of 2/3. Alright? Now we've got to go on to find the value of this. Now, again, 8 to the power of 2/3, I could split it up into 8 to the power of a third times 8 to the power of a third. And because I know that when I multiply the same base numbers, I add the powers. And adding 1/3 and 1/3 gives me 2/3. So 8 to the power of 2/3 is the same as 8 to the power of a third times 8 to the power of a third. Why have I done that? Because I know that this says the cube root of 8. 8 to the power of 1/3 is the same thing as the cube root of 8. So that's the cube root of 8 as well. Well, the cube root of 8, you should know, is 2. And so this is really the same as 2. That's really the same as 2. 2 times 2 is 4. So, going back to your original question, 8 to the power of minus a third, all brackets, all raised to the power of minus 2, is exactly the same thing as 4. Yeah? Very, very simple idea, and it all stems from knowing what 8 to the power of a third means, and that comes from breaking this power up into a third, add a third there. Okay? Let's do another example. This looks even harder, but again, if we do it carefully, we will be able to work it out without any problems. You've been asked to work out 16 to the power of a quarter times 32 to the power of 2/5. Now, the two base numbers are not the same. Be careful, they're not the same. That's a 16, that's a 32. So don't go and just add powers. You cannot do this. You've got to work out that separately, and only then start multiplying your answer. Well, let's see how it works. We know that 16 is 2 to the power of 4. You should know that. Again, you see 16, you should think, it's 2 to what power? 2 to the 4. And all of that is being raised to the power of a quarter. Times, well, 32 is, again, 2 to the power of a fifth. When you see 32, you should think to yourself, aha, this is another one of these numbers that can be written as 2 to some power. Just like 16 can be written as 2 to some power. Now, this is all here raised to the power of 2/5. Now, once you've got this into this form, you should now see it as a power of powers. A power of powers. And you can simply multiply the powers. So, 2 to the power 4 raised to the power of a quarter is 2 to the power of 4 multiplied by a quarter. Here with this one, it's 2 to the power of 5 times 2 to the power, 2/5. And we get the following. We get 2 to the power of 4 times a quarter. Well, 4 quarters is just 1. Oops, let me lift that up a bit. There we go. 4 times a quarter is really 1. So this is just, all of this is just the same as 2 to the power 1. Here we've got 5 times 2/5. Well, this 5 and that 5 can cancel out, because it's a bit like doing this, isn't it? It's a bit like saying 5 times 2/5, and those 5's cancel out, leaving you with 2 on the numerator. There it is there. So all of this is really the same as 2 to the power 2. Now the base numbers are the same. 2 there, 2 there, and we're multiplying them, so we just add the powers. So 1 add 2 is 3, so it's 2 to the power 3, which you should now recognize as being 8. So in other words, this thing here, 16 to the power of a quarter times 32 to the power of 2/5, is exactly the same as the number 8. Now, let's finish off. Well, I've written it down there, look, see? It's exactly the same thing as 8. You could actually put this 16 into your calculator, raise it to the power of a quarter, multiply by 32 in your calculator, raise it to the power of that, and you'll find it comes to just 8. Now let's look at one more example. This next example looks quite difficult, but in fact, again, if we break it up carefully and follow the rules, it should work out nice and easy. Supposing you've been asked to solve this question. Let's get it in the right place. There we are. There we have 10 raised to the power of 5n plus 7 is equal to 0.00000001. It looks horrible, but it's not, because all of this is just a disguised way of writing 10 to some power. Notice you've got 10 to some power here, okay, and you must get the base numbers the same on both sides of the equation before you can start playing around with the powers. This is just 10 disguised to a certain power. Let's have a look how to do it. Well, there were 1, 2, 3, 4, 5, 6 zeros in front of the behind the decimal point, and you should know that that is equal to 1 over this number here, which is 1,000,000. So that decimal on the previous page that was on the right hand side of the equation, that is the same thing as 1/1,000,000th. Now, from what we've previously shown you, 1 over 1/1,000,000th is 1 over 10 to the power of 6. Yeah? Now, 10 to the power of 6, 1 over 10 to the power of 6, if I bring this 10 to the power of 6 up to the top, then the positive 6 will change to, yes, you've guessed it, to a negative 6. Now look at the equation that you've got. You've now got the base numbers, 10, the same on both sides. Only when the base numbers are the same on both sides can you therefore say that this power, all of that power, must equal all of that power. And you can make the equation then that 5n plus 7 must equal -6. Okay? And you have to solve this very simple linear equation, and you begin by taking away 7 from both sides. This add 7 take away 7 gives 0, and you're left with the right hand side being -13. You've still got your 5n here. To get rid of that 5 multiplying the n, you must divide both sides of your equation by 5, as I have done there. This 5 and that 5 now cancel out, and you're left with just the n by itself is equal to -13/5. Okay, now that brings us to the end of this video lesson, tuition lesson number 2. Go through it again if you're unsure of things. Do try your own examples, and I certainly hope that I've helped to explain things in a clear fashion for you. Any problems, don't forget you can email me at the address shown on the website. Okay, thank you very much.